Hello class, Dr. Bans here. So let's continue our discussions on sampling theorem. Okay, so now let's take a look at this diagrams that I have here. Okay, so now here, what we do is that this one, M of t, is my message signal. Okay, M of t is my message signal. Okay, and then minus FM to FM. I just taught you what? Filters. Okay, filters. So that is what? A band of frequency. A filter which has a band of frequency from minus FM to what? FM. So that means that I am going to use this filter or this band of frequency to limit my signals. Okay. So now what will happen is that my multiplier or sampler here will multiply my M of t and my delta t. What is M of t? That is what? Message signal, M of t. And then what is delta t? That is what? My impulse train signal. I discussed this one with you in my previous lecture. So it will multiply the message signal and then the impulse what? Train what? Signal. Okay, with by the what? Within the range of this what? Spectrum. Within the range of this what? Filter, or within the range of this band of what? Frequency. So that any frequency that is beyond this particular band will not actually be what? Will not pass through. Okay, so now this multiplier will multiply the message signal and then my what? My impulse train what? Signal. Okay, then it will give me what? G of t, which is what? My sampled what? Signal. My sampled what? Signal. Okay, then I will find this spectrum, which is used for what? For reconstruction of what? Of my original message what? Signal. Okay, so basically this is how it is actually what? Done. Okay, to go into much more technicality will be that before I use my impulse train signal, I must set the value for the impulse train signal. To set the value for the impulse train signal, I must use what? Fourier series. Okay, so let us see how we can use Fourier series to set what? The values for the what? Impulse train what? Signal. Okay, all right, so let's continue from here. Okay, so I know that the impulse train signal. Okay, I know that here delta of what? T is actually equals to what? A naught plus what? Setting the values for my impulse train signal. Okay, here n is equals to what? 1. Okay, here is what? Infinity. Okay, I have an cos what? N omega naught what? T. Okay, plus what? Bn sine what? N omega naught what? T. This is what I have. Okay, this is what I have. So now I know that A naught is equals to 1 over what? Ts integral of what? Minus T over what? 2 T over what? 2. Okay, delta of what? T d what? dt. Okay, but I also know that here with respect to impulse train signal, okay, my delta of t occurs at an instance, which is what? Delta t is equals to what? 0. Okay, which is what? Delta of 0. Okay, so basically here the range doesn't really what? Matter to me. Okay, because I know that delta it occurs at t is equals to what? 0. So t what? 0 at an instant point, and it's equals to what? 1. Okay, I know that a naught is equals to what? 1 for what? Impulse train signal. So in that case, I'm going to have a naught is going to be equals to what? 1 over what? Ts. Okay, for impulse train signal, this particular place becomes what? 1. Okay, becomes 1. Okay, so 1, which is equals to 1 over what? Ts. This is because impulse train signal occurs at an instance. Okay, it occurs at an instance. So here I'm not going to have to consider the range. An instance of what? T is equals to what? 0. I mean t is equal to 0 at the point of 0. That's where the impulse train occurs, and the value is always what? 1. The value of the impulse train is always 1. So that means that impulse train is what? It has a value of 1. So 1 over ts into what? 1, which will give me 1 over what? Ts. Okay, so that's my what? A naught. Okay, so now let me just find my an. Okay, so to find the an, you just have 2 over what? Ts into what? Summation minus t on 2, and then here is t on what? 2. Okay, so I'll have here to be what? Delta of what? T into what? Cos n. Okay, omega naught what? T d what? dt. Okay, so this one will give me but I know that delta of what? Delta of t is equals to what? 1. So basically this thing I have here is equals to what? Minus t on what? 2 into t on 2. Okay, so it becomes what? Cos n omega naught what? T d what? dt. Okay, so that is what I have. Okay, so now this is what I'm actually going to have, but I have to bring the 2 over ts here. So 2 over what? 2 over ts. Okay, so basically what I'm saying that I have is that a naught is equals to what? 2 over what? Ts. 2 over ts into what? Minus t on 2 into what? T on 2 into what? Cos n omega naught what? T dt. Okay, so that is what I have. So now if I have this one and then I put in my values, what's going to happen is that t naught, okay, this t here is going to be what? 0, because impulse train occurs at an instance of what? 0. So I know that if here is going to be 0, then that means that, sorry, this is an, it's not a naught. Then my an is going to be what? 2 over what? Ts into what? Into minus t on 2 into t on 2. Okay, cos what? N omega naught. The t here is what? 0 for impulse train. Okay, for impulse train, this t is 0. Okay, just as here, I made it what? 0, and I got 1. Okay, here is what? 0. And what is cos 0? Cos 0 is actually what? 1. Okay, cos 0 is actually 1. So that means that I'm going to get what? 1. Okay, so that means that my an is going to be equals to what? 2 on what? Ts into what? 1. Okay, which is equal to what? 2 on what? Ts. Okay, so that will be my what? My an. Now let me go to my bn. Okay, so now if I want to find the bn, then it is also going to be 2 on what? Ts. Okay, minus t on 2 into what? T on 2 into sine n omega naught what? T dt. Okay, but I know that here t is what? For impulse train, t is what? 0. And I know that what is sine 0? Sine 0 is what? 0. So that means that I'm going to have 2 over what? Ts into what? 0, which is equals to what? 0. Okay, so now here my overall equation for this delta of t value, for the delta of t value which I am calculating, is going to be equals to what? It's going to be equals to 1 over what? Ts for the a naught. Okay, plus what? Summation n is equals to what? 1 up to what? Infinity. Up to what? Infinity. And then I got an to what? 2 over ts. Okay, 2 over ts. So 2 over ts, I can bring it outside like this. 2 over what? Ts outside like this. Into times what? Times cos omega naught n. Okay, times what? Cos what? Omega naught what? N. Okay, so I can say that it's equals what? 1 over what? Ts plus 2 over what? Ts into summation here infinity. N is equals to what? 1. Okay, so cos what? Cos n omega what? Naught. Okay, not what? Not t. Okay, so basically this is what I am going to have. Okay, this is what I'm going to have. So now, this is how I'll be able to set my what? My dt value, my impulse train value, to multiply with the what? With the message signal. Okay, okay, so that it will give me my g of t. Okay, which I will use for the analysis. Okay, so now, knowing this one, we can just proceed to how we can find our g of t. So we know that our g of t is what? Is a multiplication. G of t is a multiplication between what? Message signal m of t, and then what? The impulse train delta of what? T. So these are the two signals that multiplies to give you what? Your impulse train what? These are the two signals that multiply to give what? To give you your discrete time signal. This g of t represents the discrete time signal, which is a multiplication of the impulse train and the message signals. Okay, so now this is what you can have. So now here, you can see that g of t is equals to 1 over what? Ts. Okay, 1 over Ts, okay, into what? Into m. I'm just taking the Ts out, okay, into what? M of t. M of t, okay, plus what? Plus what you have here, okay, plus what you have here, okay. So basically, it will be what? M of t. It will what? Multiply. It will multiply here, okay. It will multiply. This m of t will multiply here and also multiply here, okay. So it will, this m of t, see that it's multiplying delta of t. So it will multiply what is here and also go and multiply what is here, okay. So it, when it multiplies what is here, I'll get this one because I've taken this one out. And then when it multiplies what is here, I'll get m of t into this whole thing, okay. This whole thing here, okay. This whole thing here, I will just say that this 2 over ts is part of this. So I'll write everything like this, okay. I can just write everything like this, okay. So here n is equals to what? 1. Here infinity, okay, cos what? N omega naught what? T. I've taken the 2 over ts as being part of this one, so that I can simply write it this way, okay. All right. So basically, this is what you're going to what? This is what you're going to have. All right. This is what you're going to have. Now, if you should expand it, then you're going to have 1 over what? Ts into what? M of t plus, let's say n is equals to 1. If n is equals to 1, you're going to get what? M of what? M of t into what? You're going to get m of t into cos. If n is 1, m of t into what? Cos 2. Okay. So I'll get m of t into what? 2 cos omega naught what? 2 cos n omega naught what? T. Okay. All right. Okay. Yeah, that's what I'll get. Okay. Because you see that. Why am I saying that I'll get this one? Okay. Because you see that this, I've brought what? 1 over ts out. I've brought 1 over ts out. So I'll have what? 2 here. I have 2 here. Okay, I have 2 here. I brought 1 over ts out, so I have 2 here. So now I'll get what? 2 cos n omega naught what? T. Okay. Plus, if n is 2, what will I get? I'll get what? M of t. Okay. I'll still get m of t, all right. And then I'll get 2. Sorry. I'll get 2 cos 2 omega naught what? T. And then it can what? Follow up to any limit that I may have. Okay, any limit that I may have. Okay, so this is basically sample of what I can have. So now, if I have this one, then what I'm going to get is I'm going to get 1 over t on s. 1 over t on s to be equals to here. Okay, here. If I should find this one, okay. Let me write here again, m of what? M of t, okay, plus m of what? T into 2 cos n omega naught what? T plus m of what? T into 2 cos n, sorry, it's not n, it's 2, okay? 2 omega naught what? T, all right? So basically, this is what I have, okay? So now, you see that if I should find the Fourier transform of this one, okay? If I should find the Fourier transform of this one, then I'm actually going to get what? J of both sides. If I should, let me say, find Fourier transform of both sides, okay? Then what I'm going to get is that I'm actually going to have J of omega is going to be equals to here. If I find, I'll get what? M omega, okay? I'll get M omega. Then here, if I find for here, what will I get? Okay, here, what you should know is that this place I'm going to get plus, okay? I'm going to get plus, but I'll get M of what? Omega plus omega naught. Why am I saying that? And then here, okay, and then here too, I'm going to get plus M of what? Omega plus what? 2 omega what? Naught. Okay. Why am I saying that? Because I know that cos what? Cos n omega naught t is actually equals to ej omega naught. Okay, ej omega naught t plus ej minus omega naught what? T over what? 2. Okay, over 2. So the 2 here, this 2 here, it will cancel this 2. Okay, it's the same thing for this one too. The same thing, the same expansion for this one too. So this 2 will cancel this one. Okay, all right. So now, if you have any Fourier transform of this one, okay, it's time shifting. Okay, it gives you omega plus what? Omega naught. Okay, so that's why I'm going to get omega plus omega naught. And here, this 2 here is what is bringing about this 2. Okay, so this is what I'm going to what? Get. Okay, so if we should do an expansion for this one, then I'm going to get 1 over what? Sorry, so here 1 over what? Ts. I'm going to get 1 over Ts, okay, into, if it should be a long series, then this is what I'm going to get. Here up to what? Infinity, n is equals to what? 1. Okay, let's say n is equals to 1. I'm going to get m of what? Omega minus n omega what? Naught. In case it's a long what? Expansion, and I want to what? Do a summation for all of them, then it's going to be like this. Okay, so this is going to be the spectrum of what? Of my sampled signal. Okay, so this is the spectrum, okay, of the sampled signal. Okay, okay, for reconstruction. Because you see that if I want to do reconstruction, what will I have to do? I'll have to find the inverse. I'll have to find the inverse Fourier transform of this one, of this spectrum. Okay, I have to find the inverse Fourier transform of this spectrum to get my what? My reconstruction back. So when I say the spectrum of the signal, you see that I told you that this place is called what? The spectrum. Okay, this one is what? The spectrum for what? For reconstruction. Okay, so this what I have here, okay, the value here is what I'll use to determine this particular spectrum for the reconstruction of the original signal. Because if I find the inverse Fourier transform for this, the inverse Fourier transform for this Fourier transform or for this spectrum, then I'll get the original signal back. Okay, so that is some of the applications of what? Fourier transforms, how it is used in real time signals. Thank you so much. See you later.